keep deleting whichever is not of high priority, that is which is taking a longer path, those elements will be deleted. How do I delete it? By using this condition. Okay, for every vertex u in V2 Vt that is adjacent to u, that is one vertex is u, the vertex that I am considering will be u. From that to all the other vertices, what I do is d of u plus weight of u into u is less than d of u. This is the condition that we have to check, and then remove the vertices from the priority queue. Okay, so this is the algorithm. Now we will see how to execute the program. So we will now see the execution part. So I will create a new class. Then after I create, I can just type my program, save the program and check for any errors. I don't see any errors here. So I'm finding out a matrix with distance matrix, sorry, distance array to write down all the distances. Then I have a cost matrix. Then I write a function calculate where I am passing the source vertex S as well as the number of vertices. Here I have a flag, array flag, which will have the size of the array will be n plus 1. Then I also have I minimum position, which is initialized to 1, k, c and minimum. So for I is equal to 1, the array for all the elements from the source elements, I am initializing the distance with the cost. The distance array I am initializing with the cost that is required to travel from one vertex to another vertex. Then I am initializing c is equal to 2. There is a variable c which is initialized to 2, which means to say that I have to start considering from vertex 2. Okay, and then while c less than or equal to n, minimum is equal to 99. So everywhere I told you that the distance will be initialized to infinity first. Okay, so there is no infinity. I can't write infinity here. So instead of initializing something to infinity, what I am doing is I am considering 99. Initially all the distances will be infinity. I can't write a infinity here. So instead of infinity there is a 99. So for k is equal to 1 to n, what I have to do? I have to check if discharge distance k is less than minimum. That is, whatever distance I am trying to find, if it is less than infinity, or we will later on update minimum also. If this condition is satisfied, the present condition is less than the minimum and flag of k is not set to 1. See, initially flag is 0. Okay, if the distance, I don't consider the distance, then I initialize the flag to 1. So I mean, to indicate that the particular vertex is already visited or not, to mark if it is visited or not, I use the flag. So if flag is not 1, it means to say that that particular vertex is not visited. What I do, then I update my minimum value, and minimum position is updated to k, that is the vertex. Suppose I am trying to find out the value from 1 to 3. If 3 is not visited and 1 to 3 is initially infinity, if whatever is the distance from 1 to 3 is less than the infinity, then I update. And once I visit a node, what I do is I make that node as visited. Flag of minpos is equal to 1, that is visited. Then increment the value of c. The c gets incremented to the next vertex, and this happens till it covers all the vertices. This is the implementation of the algorithm. Here we know what is happening here. I'm taking the number of nodes, then I'm taking the cost and weight of each nodes. Then I'm trying to read the source vertex. Okay, then I call calculate, which goes there and finds out the shortest path and returns the shortest path from there. And then I print the minimum cost from source to destination. So this is about the program. We will now execute the program. I say the number of nodes to be 6. So let me take complete matrix to be number of nodes is 6. Okay, it's a quite, it became a little bigger value, so we will change the value now. Okay, I will run it again. We will give a shorter value. So now let me enter the number of nodes to be 3. Now it's asking me for the cost matrix, which I say 0, 2, 5, then 9, 9, 9, 0 and 2. This is the graph I'm using. 999, 999 and a 0. I have entered the cost matrix and it is asking me to. So from the matrix, I understand that there are 3 vertices and now I'm entering the source vertex to be 1. From source to destination, it's giving me source 1 to destination 2, the minimum cost is 2, and source 1 to destination 3, the minimum cost is 4. So it is finding the shortest path to all the vertices from the single source, and also it's giving me the cost. What is the path as well as what is the